So our lab does electroanalytical chemistry. That means we take students from analytical chemistry, materials chemistry and biochemistry, and we deal with a range of electrochemical techniques. Overall, we work with biosensors and electrocatalysts and electrochemical microscopy. So the three examples of how interdisciplinary electrochemistry is as a method. We employ single-stranded DNA aptamers in electrochemical biosensors because they can give us information about analytes with high specificity and sensitivity. We also measure multiple analytes simultaneously with our electrodes that we build in-house, and we apply these to a range of systems including electrochemical and ion conductance microscopy, so we can map out chemical concentrations of analytes over particular substrates. The information we collect from these measurements can tell us about how the cell morphology is changing, how the topography is changing, and under the influence of certain drugs. So we want to use these biosensors but really understand the mechanisms by which they work. And if we can do that, then we can hopefully address new analytes, improve the performance of the biosensors, and apply these to new systems that have not yet been explored. These include things like electrochemical microscopy, where these types of sensors have not yet been used, and so we're really trying to develop the methods that enable that to happen. In our lab we have a home-built electrochemical microscope that can do electrochemical and ion conductance measurements, which means we can map out the spatial concentration of an analyte around a particular substrate of interest. And so we'd like to use our biosensors in that instrument and hopefully use multiple electrodes so that we can measure multiple analytes simultaneously that are being released over a substrate that could include things like a living cell at the single cell level. We're also investigating transition metal nanocarbides for their role as electrocatalysts for water splitting. And this includes investigating how the roles of different metals in multimetallic systems can affect the electrocatalytic performance. So most students don't have an electrochemistry background coming in, so we make sure everyone's fully trained in electrochemistry, but also analytical chemistry, how to deal with materials, bioanalytical methods. People also have a good grasp of coding, dealing with large data sets and being able to understand the data and extract the information you need. We also work with 3D printing in the lab to build bespoke systems for our electrochemical setups. And we also take advantage of the departmental facilities and campus facilities such as electron microscopy and X-ray diffraction spectroscopy.